Yeah, guys, just give me 1 minute. Uh, yeah.
వీడియో ఆన్ చేసుకోవచ్చా ఏంద్రా రే స్టాప్ ఉంటా అన్మ్యూట్
Guys, someone speaker is on now. Please mute yourself. Yeah. I'm posting a link in the group. Okay, CSC in the CSC group and VA group. And here also 1 minute. Yeah, guys. Yes, Nikhil. I have stopped sharing. Okay. So yeah, fine. Yes, guys. Now I have posted a link, YouTube link in the group. Okay. So students, whoever cannot join in the Zoom, okay. So whoever cannot join by Zoom, they can join by using this YouTube link. Okay. Fine. We'll proceed with the class now. Yes. Okay. Oh God, everything is gone. Let it be. Okay. So fine. Okay. So fine. Yeah. No issues. However, so we are discussing, yes, guys. We are discussing circle linked list. Okay. So what is the main difference between single linked list and circle linked list? Okay. So it is like single linked list. Last node will have. So for example, if I take 4 nodes. Okay. So 100, 200, 300, 400. Okay. So this will store address of the second node. This will store address of the third node. This will store address of the fourth node. And the last node will store the address of the first. Last node will store the address of the none, because it is a single linked list. Okay. So for example, I'm taking 10, 20, 30, 40. Okay. The same thing. If I take a circle linked list. Okay. So here also single linked list, single circular linked list. Okay. So I can tell this is single circular linked list. Okay. So here also 100. If I take addresses as 100, 200, 300, 400. Okay. So first node will store the address of the second node. Second node will store the address of the third node. Third node will store the address of the fourth node. And the fourth node, which is nothing but the last node, what will store? Yes. The last node will store the address of the first node. Yes, 100. Okay. So if this is the case, okay. So do we need, yes guys, do we need head part in the circle linked list? So if you observe in single linked list, actually we need head part because we need to store the address of the first node. Okay. So in circular linked list, do we need head node? Yes, Nikhil, I hope you can see the screen now. Yes, guys. Do we need head part in circular linked list? Yes or no? Yes. Any answers? Do we need head part in circular linked list? Okay, some people are telling no, some people are telling yes. Okay. Okay. Yes, no, yes, no, yes, yes. Okay, fine. We'll see. First thing here, why we need head part here? We need head part to get to the first node. So if I can get to the first node, I can access second node, third node, fourth node. Okay. So most of the people are answering actually not needed. So if you observe the link, so this is pointing to this thing. So this is pointing to this thing. Okay, and this is pointing to this thing, and this node is pointing to first node. Okay, so people, whoever is answering no. Okay, so first thing, if I need to get the first node, I should come to the last node here in circle linked list. Yes or no? Yes, in circle linked list. Nikhil, you are telling you cannot see the screen. I am sharing the screen. Okay. So yes, guys. Yes, people. Is screen is visible? Can you see the screen or whatever I am sharing? Whatever I am sharing. Yeah. Yes, Nikhil. I think something problem with your network or something. So everyone can see the screen. Please check it. Okay. Okay, guys. So if you observe here in circle linked list. Okay. So in circle linked list, actually, why we need head part to come to the last node? Yes, sorry, head part we need to come to the first node. Okay, so but in circular linked list, I can come to the first node by using the last node. Okay, so how will you come to the last node? You need to come to the, for example, if there are four nodes, so if I want to come to the first node, I can come by using fourth node. Fourth node, how will you come? Third node by using third node. Third node, how will you come to third node by using second node? How will you come to by using? How will you come to the second node by using the first node? How will you come to the first node? You'll come to the fourth node. Okay. So here the problem is, if you need to come to the first node, you need to come to the last node. Yes, if you need the first node's address, you need to get the last node's address. Yes, guys. So tell me, how will you get the last node address? Are you understanding what I am trying to tell? Here, first node address is stored in head. Okay, so you can access second, third, fourth. Here, so many people are telling that. Yes, yes, size 3. Is my voice clear now? Hello, is my voice clear? Yeah, yeah, fine, fine, fine. Thank you, guys. Yes, what I was telling is like here in single linked list, if you want to come to the first node, you'll come to the head. So after coming to the first node, you can access all the nodes. Okay. So, but many people are answering that in circular linked list, we don't need head part. Okay. So first thing here. Okay. So why, for what purpose we were using head part to come to the first node? Okay. In circular linked list, if you want to come to the first node, you can come by using the last node. Okay. So now my question is, how will you come to the last node? Is how will you come to the last node? For example, if you take last node as the fourth node, so okay, fine. You can tell, sir, fourth node I can come to. I can come from third node. Yes, and you can tell third node. You can come from second node. Okay, from second node you can come to second node by using first node. Okay, so if you want first node, you need the last node. And if you want the last node, you need the first node address. Yes or no? Okay. So the problem is here. I can tell circle linked list is nothing but a loop. Okay. So if you enter into the loop, you can get any address or any node's address. Yes. So my question is, how will you enter into this loop? Yes. If you enter into the loop, you can get either second, third, fourth, or first. Okay. So the question is, how will you enter into this loop? Okay, so we need to enter into this loop. So after entering into the loop, you can get any node address. Yes. So how will you enter into this loop? Yes, guys, any answers? How will you enter into this loop? People are telling pointer. Guys, in Python, we don't have any pointer. Yes, and someone raised hand. Yeah, fine. Yes, guys, how will you enter into this loop? So obviously, if you want to enter into this loop, you need a variable which points to the first node. Exactly, Lakshmi. Yes, what we need? We need a variable which is pointing to the first node, actually, which acts like a pointer. But in Python, we cannot call it as a pointer. Okay, so we'll be calling it as just a variable. Yes. So if you observe here, it will store the address of the first node. Okay. So if you observe, even in circular linked list, we need head variable. Yes, sir. No. Because if you don't create a head variable and make it to point to first node, you cannot come to the last node. If you cannot come to the last node, you cannot come to the first node. So I hope everyone is clear that even in circular linked list, we need head variable. Yes, sir. No. People whoever answered no, I hope you got a clarity. If you did not get a clarity, please respond. Yes. Okay. So fine. Yes, guys. So if you observe in circular linked list, we'll be having two variables or two variables pointing to the first node. One is head variable and one more is the last node. Yes. Okay. So now we'll see a program for this now. Yes. So we'll just see two functions. I'll just write insertion at the end and display basic things. Okay, so or we'll just see three functions: insertion at end, okay, so deletion at end and display in a single circular linked list. Okay, so yeah, give me just 1 minute. Yeah, guys, 1 minute. First let me clear all these drawings. Okay, so shall we proceed to the program now? Yes. So just like normal, we'll also create a class. Okay. So I'm creating a class node. Okay. So I'm creating single circular linked list. Okay. So yes, init underscore. Okay. So we'll be having first variable as self. I hope everyone knows this. I'm not repeating these things again. Okay. So and whenever we want to create an instance variable, okay, so we'll create it inside an initial constructor. Yes. So for this node, what we need to do, we need to pass some variable. Okay. And whenever I'm creating my node, I'm just writing self dot. Okay. So self dot 1 minute. Okay. So next. So whenever I'm creating, I don't know what is the address, right? Okay. So for that reason, so I'm just writing self dot next is equal to none. Okay. Okay. Next. So I'm just writing a single circular linked list. Okay. So I'm writing class uh, single circular linked list. Okay. Or LL, whatever. Single circular linked list. Okay. So as it is a class name, we don't need brackets here because we are not doing any inheritance. Okay. And this also definitely needs the head part, that is nothing but instance variable. Okay. So I'm writing it inside a constructor init underscore uh, self. Yeah. Next, I'm creating a head variable because every linked list should have at least one variable which is nothing but head. Okay, so here I'm in default making it as a none because initially we will not have initially head will store none. Yes. Okay. Next. Next, we'll see insertion at end first. Okay. So insert at end. So insert at end. So coming to this insert at end. Okay. So first thing is what? So obviously I'll be so whenever I call this function, I'll also send a variable which I need to store. Okay. So after this, what happens? So I should create a temporary. I should create a node. So I'm calling class name, and I'm sending that x variable. So until now, everything is same. Yes. Okay. So coming to circular linked list, one more point you need to remember. Okay. So one more point you need to remember is like generally. So how will we implement the circular linked list? So for example, if I'm just inserting one node. Okay. So generally, what people will think that so first I'll create a single linked list. Okay. So four nodes. At the end, I'll make this to point to the first node. Actually, that is not will be doing. Okay. So that is not the actual implementation. Okay. So it is not you'll create. It is not like create a single linked list and at the end make the last node store the first node. No. Okay. So that is not circular linked list is. So for example, head will be head will store the if there is only one node. Yes, if there is only one node, head will store the first node's address and first node's data. Let it be 10. So if there is only one node, so this is the last node and also the first node. Yes. Okay. So tell me, guys, if there was only one node, what should be my address here? Yes, if there is only one node in circular linked list, what first node should what should this first node's next part should be? Yes, if there was only one node in circular linked list, what should be the next part of first node or the last node, whatever it is? Okay, some people are answering null. Any other answers? Yes, or actually what it does. So if there is only one node, so this is the first node and also this is the last node. So actually what happens, always the last node should store the first node's address. So here if there is only one node, so that node will have the same node's address. Yes, if there are yes, I see. So if there are two nodes, okay, so if there are two nodes, okay, so it is like 100 and 200. Okay, so first node head will point to this first node and first node will point to the second node and the second node next part will be what, first node's address. So this will be pointing to this one. So if there is only one node, so first node and the last node is same, so it will contain the same node's address. Yes. Okay, so if there are two nodes, it is same as normal. So it is like whenever you are inserting a new node, okay, so always the last node should store the first node's address. Okay, so it is not like first create a single linked list of those many nodes. Okay, and at the end make this last node to store the first node. No, that is not the actual implementation. Is actual implementation is what? So whenever you are inserting a new node, okay, so always, so at any point of time, your linked list should be in circular form. It is not at the end. Okay, so at any point of time, your linked list should be circular. Okay, so that you need to make it clear. Okay, I hope you understood, right? If you have any doubts, please ask. Okay, so why I'm telling is because now we are going to insert the first node. Yes. Okay. Yes, guys. So here, okay. So fine. I'm just going with the normal flow. So generally, what will we do? So we'll create a node. Yes. After creating a node, okay. So what should happen? So now in default, this will have none. Yes or no? In default, it will have none. So now here, what am I doing? After creating a node, I am making it as temp dot next is equal to. So then tell me what should I write? So whenever I create a new node, it is insertion at the end, right? So in the insertion at the end, the node which I am going to insert will become the last node. Yes. So if this is going to become the last node, so this last node should store first node's address. Okay. So I'm directly writing it here. After creating, okay. So after creating a node, so I'm just pointing this last node to store the first node's address. So where will I get the first node's address? Yes. So tell me here, what should I write? So exactly happening. Okay. So here up to now, actually, what is there? I'll have head. Okay. So I'll have head, and I have created a node. Okay. So I have created a node. Excuse me, guys. I'm getting a call. Give me just 1 minute. Give me just 1 minute. It's urgent.
Mic on this.
Uh, yes, yes. I'm back. Okay. So fine. What I was trying to tell is, okay. So the thing is what, so initially, so if you observe, now we are taking the first node, right? Yes, yes. Okay. So first node, I'm making head as none. Initially head will have none. Okay. And this node, so let me take my X value as 10. So this will be made as 10. And here I'll be having none. Up to I did not create a link. Yes, 1 minute. Jay, unmute yourself and also rename Archana. Archana, mute yourself. Okay. So everyone rename yourself. There should be roll number and name. Yeah, fine. So if you observe, this is the up to now, this is what we did. Yes or no? So we have just created, yeah. So head is there, head value is none, we have made it none. So here I have created a node. Okay, so now it will be having 10 and then none. Okay, so actually what I thought is like, okay, so generally this is for first node, actually for first node. So for example, if I take it as a second node, okay, so head, and it will have none. So temp, sorry, head, if I take head as 100. Okay, so now actually what happens, so first node and the last node are same. Okay, so now this will store first node's address. So from second node onwards, okay, so from second node onwards, okay, so what we can do directly, okay, so directly, so here what I plan to do is nothing but, so for example, it's a second node address. Okay, so normally here I'll have 20. I should form a link. Okay, so after forming a link, okay, so how to form a link, that we'll see here. So what I thought is like here directly, so instead of storing none, so normally we'll store none, and here we should change it. So what I thought is like, instead of storing it none here, okay, so what I thought to do directly, so after creating, directly make this new node as first node's address, new node's next as first node's address. Yes, so that's what I thought to do here. So if I do, it will work for second node and third node also. So for example, if we take the third node, so instead of storing none here, okay, so instead of storing none, so actually what happens, so whenever we create a new node, none will be stored. So instead of storing a none here, what I thought to create, I thought directly to store second node's address, sorry, first node's address. Yes, so yeah, so this should store this should store 100, and this should store 300, and this should store 200. Okay, so fine, let it be. So we'll just go with the normal thing. So need not to make it here temp dot next, you'll get confused. So fine, let it be. So we'll just go with this thing. Okay, yeah. So if we take this insert at end, so up to now I've just created a node. So here again same, first node, I'm just making it is two conditions. If self dot head, how will you check whether it is a first node or not? Double equal to none or is none. If self dot head is none, okay, so then what should I do? That is first node. Okay, so if self dot head is none, what should I do? So I just need to do two things. What are those? So make head point to this first node. Yes, how can I make head point to the first node? Yes, yes guys, tell me, how can I make head point to the first node? Just as normal, self dot head is equal to temp. That is what we should do, right? So now head is pointing to the first node. After this, we need to do one more thing also. What is that? So this first node should store, that is nothing but the last node should store first node's address. So this node should store same address. Okay, now this is temp. So if you observe now what happens, so now instead of none, what should I store? I should store the same node's address. So if I take the address as 100, so 100 should be stored. Okay, so tell me guys, so how can I do this? How can I make it, how can I make the nodes store the same address? Yes, tell me the statement, what should I write here? You can write it in two ways. Yes, you can respond any one statement. So I want the first node to store its same address. Yes, any answers? Yeah, Abhinay. Okay, so yes, at least one person, only one person is responding. Only Abhinay, 5-8 Abhinay is responding. What about the others? Okay, so you can do it in two ways. Either you can write temp dot next, because that is a new node. Okay, temp dot next is equal to, you can write self dot head. Okay, so yeah, or okay, So, or you can also write one more thing. What is that statement? Okay, that I am making it as a comment line. Okay, so you can just write temp dot next is equal to temp. Yes, either you can write temp dot next is equal to self dot head or temp dot next is equal to temp. Okay, so yeah, so else for the other things. Okay, so what you need to do? So uh, first thing is what? So for example, okay, so this will be the case for the first node. Okay, so now let me take other nodes. Okay, so now this temp will be gone. Okay, so fine. Next, what am I doing? So next, let us take. So now, what are the conditions I am writing? Okay, so let me take three nodes because you'll get a clear clarity. So here I'm taking 20. This should store next node's address. So this store 30, and this will store first node's address. So head should store. Okay, so head should store 100. Okay, and then this last node. So last node should have store the first node's address. Okay, we'll come to this point. Okay, fine. So now else. So for the second node, third node, fourth node, now we'll write a condition else part. Okay, in else part, what happens? So I should create a node. Okay, so that will be created as temp. Okay, let me take my address as 400. Now what should I do? I should come to the last node. Yes, I should come to the last node. After then, what should I do? After coming to the last node, I need to do two things. Yes, so what are those? So first, link last node to this thing. Yes, okay. So what should I do? I need to make a last node to store to the new node, and new node should store the first node's address. Yes, these two things I need to do. Okay, so last node should store to the new node, and new node should store to the first node. Okay, so fine. Here, okay, so here, yeah, yes, okay. So yes, guys. So first my thing is how can I come to the last node here? That is the main thing actually. How will you come to the last node? Yes, guys, now I should come to the last node. So normally what we used to do, so we used to write a loop. Okay, so we used to take some temporary variable called, for example, t. So I'm just taking t is equal to self dot head. Okay, so after then normally what I used to write, okay, so I used to write t dot next not equal to none. So here we used to have some yeah, Vinay. So I have taken a temporary variable. So normally I used to do this. Okay, so what I used to do, so until I get t, okay, so 1 minute, so until I get none, what I used to do, I used to go to the second node. T is equal to t dot next. So this is how I used to traverse, or I used to come to the last node. But now we don't have none. So now tell me, how can I decide that particular node is the last node? Now tell me what condition I should write. So normally I used to write, so whenever my last part is equal to none, okay, so whenever my next part is equal to none, so that becomes the last node. So but here we don't have uh, last part, right? So here we don't have none. So then tell me, how will I find that this is the last node? Exactly. Okay. So yes, Suvarna, what will we do? So instead of none, it will have what? It will have the first node's address. So what will I do? So I'll always, so instead of comparing it with a none, I'll compare it with the first node's address. Okay. So normally what I used to do, I used to do t dot next not equal to none. So I used to write t dot next not equal to none. So because last node used to have none. So but here what will have, last node will have first node's address. Yes. So now instead of comparing it with a none, I'll compare it with the first node's address. So where will I get the first node's address? Yes, guys. Where will I get the first node's address? So now next, I should compare with the first node's address 100. 300 is not equal to 100. 100 is not equal to 100 first. That is not when this is the 100 is not equal to the 100. Sorry. 200 is not equal to 100. So this is not the last node. 300 is not equal to the 100. So this is not the last node. Here 100 is not equal to 100 is false. So this is the last node. Yes. Okay. So where will I get the first node's address? Obviously. Okay. So we'll get the first node's address in the head part. So I'm comparing it with head. So exactly correct. Okay. So until your node, until the node's next part is not equal to the first node's address, which is nothing but head, go to that particular node. Okay. So now if you observe what happened, so now by the end of this loop, okay, so my T will be here. Yes or no? So T will point to the last node here. So after this, I just need to form links. Yes. So now, okay. So instead of this 100, this 100 should store 400. Okay. So that I'm writing it here. So I'm just writing T dot next is equal to new node's address. So where will I get the new node's address? Temp. Okay. After this, what should I do? Okay. So now what is happening? Yeah, exactly happening. So what will we do? Okay, so now what I did, so by this line, so here this will store new node's address, that is nothing but 400. So let me take the value as 40. Now after this, what should I do? So this actually will be having none, but what should I do? So instead of this none, I should store the first node's address. Yes, so instead of this none, I should store the first node's address, which is nothing but 100. So how will we do that? Yes. How will we do that? We'll do it by using temp.next is equal to self.head. Yes, temp.next is equal to self.head. Okay. So now we'll see, guys. So now we'll just see the display function. Okay. So then we'll understand whether our program is correct or not. Okay. So I'm just taking one more method called display. So what this does, this will display all the elements. Okay. So obviously, if, every linked list should have a parameter which is nothing but every method of a class should have first variable as self. So I made it as a self. So after then, it is same as until the last node I should print, right? Okay. So it is same as here, just traversing. Okay. So that's why I'm just I'll write the same lines. So what will I be doing? Will be taking a temporary variable t is equal to self dot head. Okay. So after doing that, so take a while loop. So here until the last node. So how will I come to the last node? How will I know whether that is the last node or not? Okay. So by using by comparing it with the first node. So how will I get the first node's address? Self dot head. Yes. So here what I need to do? I need to print. So I am printing. So printing what? Print t dot data. Okay. So and I'm making end is equal to. Let it know. So if you want everything in single line, you can just write end is equal to, okay. So, but no problem. So after printing, what should I do? I should go to the next node. T is equal to t dot next. Yes. Okay. So yeah. So now what am I doing? First, first I'm creating a circular linked list. Okay. So let me take it as A. So I'm just writing a single circular linked list. Okay. So whenever I write this thing, what happens? So head part will be created. Okay, now I created an object for a class. Okay, so after this, what should I do? Okay, so now taking in input. So first, let us assume that they are giving a number called n, that is nothing but number of inputs. Okay, so I'm taking first number n is equal to int of input. Okay, so after that, for those many times, I'll write a for loop for I in sorry for I in range of n. Okay, so for I in range of n, then every time take an x value. Okay, so x is equal to int of input. Okay, so after that, what I need to do? So every time I need to insert. So if I want to insert, uh, okay, so that is nothing but here a is an object of a single class, a single circle in this. So I am calling so a dot inserted end. A dot inserted end. Okay, so what is inserted end of x? Yes, inserted end of x. So how I'm giving inputs? So first, let me take. I'm taking 5 inputs. So what are the inputs? 1, 2, 3, 4, 5. Yes. So this loop will run for 5 times. Okay, and then those 5 values I'm giving. So after giving input, then I'm checking it. Display. Okay. So a dot display. So I just need to get all the elements one time. Okay. So yes, it is showing single circular linked list is not defined. That means there is some mistake with the class name. I've made C as capital, so here also C should be capital. Yeah, so we are not getting the last node. Yes, okay. So as we are not getting the last node, why we are not getting the last node? I hope you'll understand. Yes, so here when you come to the last node, so here 100 is not equal to 100, condition failed, so will not enter into the loop. Yes, so for that reason what you need to do, so after coming out of the loop, then we should write t dot data. Yes, Abhinay, that is what. So after while loop, I just iterate t dot data, because so whenever I check dot next, okay. So whenever I check dot next, so here it will not enter into the loop for the last node, because 100 is not equal to 100 is false. Okay. So for that reason, I will not enter into this loop. So if I am not entering into this loop, I will not be printing the data. Okay. So now let us execute. Yeah. 1, 2, 3, 4, 5. Yes. Okay. Next, we'll see the last function in this. So deletion at end. So I'll just tell these 3 things. So remaining you people try. So if you're not getting, you can ask me. So because again, if I start explaining all the things, okay. So even in single circle linked list, it will take 2 more days to complete. Okay. So for that reason, I'm just telling you insertion at end, deletion at end, and display. Okay. So delete at end. Yes. So delete at end is actually same. Okay. As normal. Okay. So what do we need to do? We need to come to the last node first. Yes. If I need to come to the last node, what I need to do? I need to come to, yeah. Yes. So tell me, if I want to delete at end, I should come to the last node or last but one node? Yes, guys. So if you observe this here, here we already have linked list. Okay. So it will be better if I come to the last node or last but one node. Now this is the linked list we have. Yes. Now I need to delete the last element. So if I want to delete the last element, what should I do? Yes. Any answers? I want to delete the last node. So if I want to delete the last node, what should I do? Yes. Yeah, exactly. So what will we do? So we'll come to the last but one node. That is nothing but t. Okay. So after coming here, I should delete this thing. Okay. And then this should store first node's address 100. Yes. Okay. So come to the last but one node. Delete the last node. and make this part next as the first node. Okay, so now tell me guys, so I should come to the last but one node. So tell me what should be my condition here. So I'm just writing self.head. So now I should stop at last but one node. Tell me what should be the condition. Okay, so if people tell me, I'll write down t is equal to t dot next. I should stop at last but one node. If I need to go to the last node, I'll write t dot next is not self head. Yes, but I want to stop at last but one node. Then tell me what should be my condition in the while loop here. What? Yeah. What should be my condition here? I should stop at last but one node. Any answers? Anyone from CSC? I'll call some names. Archana, Vaishnavi, Bharat. Anyone? Vishal, Harish, Sharanya, Nitin, Venkat, Pavan, Kashyap, Kavya, Abhinay, Sadhana, Satvika, Umar, 510, Vineet Reddy. Any answers? So I should stop at last but one node. So what should be my condition?
Yes, sir.
Yeah, guys. Try to tell me what should be my condition in the while loop such that I'll be stopping at last but one node. Yeah, at least one person has responded. Yes. So I, instead of checking t dot next, yes, Suvarna, we should write t dot next not equal to self dot head. Yes. So go to the last but one node. After going to the last but one node, I should delete the last node, right? So I'm writing delete t dot next. Yes, if t is at the last node, last but one node, I need to delete the last node. So I'm writing delete of t dot next. So what is t dot next? T dot next is 400. So I'll delete 400. After doing that, what should I do? So if this becomes the last node, this should store the address of the first node. Okay. So I'm writing t dot next is equal to self dot head. Self dot head. Yes. Okay. Now let us see. Okay. So here I'm calling delete at end. Delete at end. Okay. So after then, what am I doing? Now again I'm displaying. Let us check whether code is working or not. Yeah. So if you observe previously, initially 1, 2, 3, 4, 5. So after then 1, 2, 3, 4. Yes, guys, this is about single circular linked list. Okay. So single circular linked list. Yes, guys. Yeah. 1 minute. We'll take a break. Yeah. So before going to the break, everyone send your roll numbers in the chat box. Yes, guys. Okay. So yeah, the time is 11:40. Okay. So we'll meet at 11:55. We'll meet at 11:55. Yes, guys, if you have any doubts, please ask. Uh, okay, guys. Yeah. So now let us see double circular linked list. Okay. So what about this double circular linked list? It is also same. Uh, yeah, same as the single circle linked list, but we can also traverse forward and backward. Yes, that is the only thing we need to remember. Yes, here also we'll be having a head part as same as single circle linked list. Okay, so yeah. Here also we'll be having a head part. So 100, 200, 300, and 400 if I take. Okay, so normally first node will have second node address here 200. Okay, and coming to this node will next will have 300. Previous will have first node, that is 100. Okay, and coming to this node, this will have next as 400 and previous as 200. Okay, so coming to the last node previous will have previous node's address, that is 300. What about the next node's address? Yes, what about the last node's next? Yes, as it is a circular linked list. Yes, guys, it is a circular linked list. So what should have last node should have first node's address. That is nothing but 100. Yes, and coming to here, head will have first node's address. And what about the first node's previous? Yes, this is all fine. What about first node's previous? Exactly. First node's previous should contain last node's address. Exactly. Akshay and Abhinay. Okay. So and Dharani. So yeah. So this should have last node's address. So what is last node's address? 400. Yes. This is about circular linked list. Yes. Okay. So now we'll try to write. I hope everyone understood the logic behind here. Yes. Okay. So coming to here, we'll be having next and previous, right? So I'm creating next and previous. Yes, guys. So if you have any doubts, please ask. Yeah. So if only one node, yes, we'll come to that point also. Okay. So self dot previous. So I'm just creating a node which has next and previous. Okay. And if there is only one node, then what happens? Okay. So we'll come to that part here. So I'm just modifying the same code which I have written for single circle linked list. Okay. So we'll come to that part also. Okay. So here it is double circle linked list. Yes. Double circle linked list. Even here it will have head part. So I'm making it as done. So coming to insert at end, first I should create a node. Okay. So after creating a node, so this is for what? So yeah, we'll come to we'll change this thing. Okay, so now we should write a logic to insert the first node. Yes, logic to insert the first node. Okay, so as Abhinay, we'll see what if we have only one node. Yes, okay. So what if we have one node? So what happens? Head will be there. Okay, so if we have only one node, okay, so 100. So head will store first node's address, and coming to the this should store first node's address. Yes, next part should store for if I take this as the last node, this should store first node's address. That is nothing but 100. Okay, and here previous should store the last node's address. So what is the last node's address? Last node's address is also 100, and here I'll be having a data called 10. Yes, guys. So if there is only one node, next and previous should be same, because next is also same and also previous everything. So here even if there is one node, so that node's next will not store the same address, and that node's previous also will store the same address. Yes, Abhinay, I hope you are clear. If there is only one node, this should happen. Yes. So now we'll come to that point. Yeah. So here we are writing a logic for this. So if there is only, if it is a first node, okay. So I'm directly writing. So first I should create a link. So head should store new node's address. So where is new node's address? Temp. Okay. And then temp dot next. Okay. So temp dot next is equal to self dot head. Yes. And also temp dot previous should also be equal to self dot head. Yes, temp dot next and temp dot previous should be equal to self dot head, because there is only one node. Okay, and then coming to the else part. Okay, so coming to the else part, that is nothing but if there are more than one nodes. Okay, so we'll come to that point. So for example, if I see it here, okay, so let us assume that there were three nodes and we need to insert the fourth node, because the condition what we write is common for second, third, fourth, everything. Yes. So if that is the case, if I take, so here this should store first node's address, this should store last node's address. Yes. This should store 100, and here we'll be having 300. Okay. So now what happens? So whatever the node we are creating, now that becomes the temp node. Okay. So this becomes the temp node. So here this will be having none, and also previous also will be having none. Yes. So let me take this node's address as 400. So now again same, what should I do? I should come to the last node. Yes. So first come to the last node. So yeah guys, so how will we come to the last node? Same. So we'll just take one temporary variable and then we'll come to the last node. So t is equal to self dot head. Okay. Condition same as previous. T dot next is not self dot head. Okay. So until it is self dot head, go to the next node. T is equal to t dot next. Yes, while t dot next, t first come to the first node, so you should come to the last node. That's why I'm checking with is not equal to self dot head. So after coming to this thing, okay, then what should I do? Okay, so then what should I do? First thing, so I should create a link, right? First, okay, so t should store t dot next should store new node's address. That is nothing but 400 should be stored here. Okay, so first I'm creating that link. Okay, so now what happens? Okay, so after coming to the last node, so now what am I doing? So now I'm just writing t dot next is equal to temp. Okay, so whenever I do this thing, so what happens? So here this link is created, so this thing will point to the new node. It's 400. After then what happens? Okay, so after then what should need to happen? Okay, so here temp dot previous should store this node's address. Yes, so if you observe this thing, okay, so this one, so here I should remove this none and then I should store 300. Yes, okay, so because it is double linked list, right? Okay, so now I'm doing that thing. So what am I doing? I'm writing temp dot previous. Okay, So temp dot previous is equal to this node's address. So where will I get this node's address? T will give me this node's address. Yes. So now what happens? So whenever I do this thing, okay. So here none will be removed, and what happens? This node's address 300 will be stored. Okay. So after then, so now here link is created. This is pointing to this one. This is pointing to this one. Okay. So after then, what I need to do? I need to make temp point to the first node and first node point to the last node because it is circular. Yes. Now I need to do last node point to the first node and then first node point to the last node. Okay. So Eclipse forming these links is very easy. So first I'm making last node point to the first node. Okay, what is the first node? First node is 100. Okay. So how can I do this? Okay. I am writing temp dot next. Yes. So temp dot next is equal to self dot head. Okay. So now what happens? Okay. So now the last node will point to the first node. Yes. So this will store 100. Now what happened? First node's previous should store the last node's address. Okay. So tell me, how can I access first node's previous? Exactly, Abhinay. Okay. So what we need to do? So first node previous should store the last node's address. Yes. Yeah, exactly. Abhinay, what will you do? So we'll just write. So how will I access the first node's address? By using head. Okay. So I'll write self dot head dot previous. So that is head is pointing to this thing. So I'm writing head dot previous. Okay. So head dot previous is equal to, okay, new node's address. So where will I get the new node's address? Temp. Okay. So now what happens? Okay. So head dot previous is this one. So this will be storing new node's address. So what is new node's address? New node's address is 400. Yes, 400 will be stored. Yeah, guys. Okay. So we just need to know, need to form these 4 links. Yes, as a double linked list. So these 2 links should be created. Okay, as it is circular, these 2 links should be created. 1, 2, 3, 4. Okay. So here, whatever you form first, it's not a problem because we can at any point of time we can access first node, we can access last node, we can access last button. Okay. So here you'll not be having any problem of losing a particular node's address. Okay, so this is about insertion at end. Okay, so and then coming to display. So do we need to change anything in display? Yes, guys. Do we need to change anything in display? Okay, so I hope everyone is clear with this thing. Okay, so I'm removing this thing. Okay, so yes, guys. Do you have any doubt in this insertion at end? So if you have any doubt, please ask because I'm planning to remove these diagrams. Okay. So and one more thing, do we need to change display function? Actually not required. Okay. So what will we be doing in this? So until we get the last node's address. Okay. So until the last node storing, and we'll be checking for the first node's address. So even in single circle linked list, in double circle linked list, we'll be checking only with the next part. Okay, so here next part is same as single linked list only. Yes, so for that reason you need not to change display function. Yes, so you just take a temporary variable. So until this next part is equal to the first node. So here if you observe 200 is not equal to 100, 300 is not equal to 100, 400 is not equal to 100, 100 is not equal to 100 false. So you'll be coming to the last one, then you'll be stopping. Yes, you need not to change display function. Yes, so yes. Okay, so you need not to change the display function. So I'm just calling these 2. Okay, so delete, we will come to this part. Okay, so we did not discuss delete, so I'm just for now insertion at end and then display. Okay, so I did the same thing. So create for double linked list, double circle linked list, right? Double circle linked list. So first we'll give n input and then it will call n times and then display. So if you observe, we're getting 1, 2, 3, 4, 5. Okay. So after then, now we'll see delete at end. Okay. Yes, guys. I hope you people are clear what I'm trying to tell. Yes or no? Yeah, Umar. Okay. Thank you for responding. Yes. Now we'll see delete at end. Okay. So coming to delete at end. So let me. Okay, 1 minute. So let me take some notes. So 100, 200, 300, 400 head will be pointing to first node. 200, 300, 400, 100. So coming to here, 300, 200, 100, 400. Yeah, this is circle linked list. So if I want to delete, yes, so if I want to delete, what should happen? Obviously, if I want to delete the last node, I need to come to the last but one node. Yes, I will be coming to the last but one node. After coming to the last but one node, what I need to do? Yes, after coming to the last but one node, I need to delete this thing. After deleting this thing, what should I do? Last, now if this becomes the last node, this should store first node's address. So 100 should be stored. Okay, and also first node's previous should store last node's address. So what is the last node's address? 300. Yes, delete the last node. Now this becomes the last node. This node's next should store first node's address. Okay, and then first node dot previous should store this node's address. Yes, that's it. Very simple. Okay, so now we'll see this process. Okay, so coming to this thing, delete at end. Okay, so if you observe up to now, what did we do? So I just took a temporary variable and came to the last but one node. So if you need to stop at last but one node, you just need to write t dot next dot next t dot next is not equal to self dot head. Yes. Okay. So after this, what I should do? I should delete the last node. If I want to delete the last node, I need to write delete t dot next. Yes. If I do this thing, then what happens? If I write delete t dot next, okay, then this thing will be gone. Okay, so after this, what should I do? I should remove this thing, should store new node's address. Yes, so this thing should store new node's address. So what is, sorry, first node's address. So that is nothing but 100. So how am I doing that? Okay, so I'm just writing easy. Okay, so now t dot next is equal to self dot head. Yes, t dot next is equal to self dot head. So first node's address I'll be getting in self dot head. Okay, and after that, what I need to do? Yes, okay. So now again same. What head dot previous should store last node's address. Okay. So what is the last node's address? Last node's address is t. Okay, that is nothing but this should store 300. Okay. So how will we do that? Yes. I will do it as self dot head is equal to, okay, so sorry, self dot head dot previous is equal to t. Okay, so now let us see whether this is working or not. Okay, so after this I am just calling delete at end, a dot delete at end. Okay, so after then I'm calling a dot display. Okay, a dot display. Yes, so let us execute and check. If you observe 1 2 3 4 5 and then 1 2 3 4. Yes guys, I hope everyone is clear with these things. Yes or no? So if you have any doubt in the linker list, please ask. By this we have completed all the linker list: single linker list, circular linker list. Okay, single linker list, double linker list, single circular linker list, and double circular linker list. Yes guys, if you have any doubt in this, please ask now. So if not, we'll go to stacks and queues. Yes. Okay guys, so next this is about linked list. Okay, so I'm not getting any doubts, so believing that you have understood. Okay, so we'll discuss stacks. Okay, so actually we can complete both stacks and queues now. It's actually very easy. Okay, so I hope everyone knows the yes guys. Yeah, it got disconnected. There was an internet issue. Okay, we'll continue now. Yes, yes. Is everyone there? Yeah, I had some internet issue. Yes, so it got resolved now. Yes. Okay. So we'll continue with the class now. Give me just 1 minute. Okay. People, whoever listening through YouTube. Okay. So 1 minute. Just check whether the link is same or not. Yeah. Okay. So yes, guys. I think link is same. Yes. Yes. Just give me 1 minute. I'm trying to resolve the issue. Yes, yes. Okay, guys. Uh, yeah. Tell me, what is a stack, or what? What is stack actually? So, what will you be doing in the stack, or at least how the stack works? Uh, exactly. Okay. So exactly, Sadhana, we can just simply tell stack is nothing but okay. Last in, first out. Yes, yes, Nandini. So last in, first out. So it is just like normally. So how this works? So what is this last in, first out? Okay. So it is just nothing but. So for example, if I take anything. So any examples of stack, guys? Any real examples of stack? Yes. Any real examples of stack? Yes, okay. So cards placed on one over the other. Yes, okay. So actually, we have a lot of examples. So, for example, if we just take bangles, so how these girls wear bangles. So first, whatever they insert can be removed first. Yes. So if I just take okay, so kind of thing. Okay. So if I just take okay, so bangle thing. So for example, 1, 2, 3, 4, 5. Okay, so if I am not good with the drawing. Okay, so fine. Yeah, bangle one, bangle two, bangle three, bangle four, bangle band. If I take this as some hand. Okay, so first I'll insert 1, 2, 3, 4. Next, six bangles. Assume that there are six bangles. Okay, so first is inserted was this one, but if I want to remove all these bangles, so first I should remove six. Next five, next four, next three, next two, next one. Yes, or pile of dinner plates. Yes. Okay. So how will you arrange files also, or discs, so which are nothing but CDs. Okay, so if you observe, there will be a CD box, DVD box. Okay, so we'll be inserting all the DVDs. So that is an example of stack. So all there are so many real-time examples of the stacks. Okay, so we'll see in how many ways we can implement the stack. Okay, so for example, we can implement these stacks using linked list, or we can just implement the stack using a list also. Okay, so first we'll see. Okay, yeah. So for example, if I take, so how the stacks work. So for example, so first, first I'm inserting numbers. Okay, so inserting numbers in this way. So for example, first I'm inserting 1, next I'm inserting 2, next I'm inserting 3, next I'm inserting 4, next I'm inserting 5. Okay, so and then, so if you observe in the stack, insertion and deletion will be done from the same end. Yes. Okay, so and if I try to delete, okay, so if I try to delete any element, okay, so first what will I get? So first, if I want to delete 1, then I should remove 5, 4, 3, 2, 1. Then only I get.
Cepra.
Yes, someone's speaker is on. Kashyap.
Hmm.
Yes, Kashyap, your speaker was mute. Please mute it yourself. Yeah. Okay. So if you observe in stack, insertion and deletion should be done from the same end. Okay. So if insertion and deletion is done from the same end, then definitely we can tell that it works like a stack. Yes or no? So first insertion was 1, 2, 3, 4, 5, and if you try to access those things, and your order will be 5, 4, 3, 2, 1. Yes. Okay. So and then coming to this stack implementation. So if you observe by using a linked list, so if you want to implement a stack by using a linked list, what we can do, I can implement it in two ways. So what are those things? So if you observe, insert at end and then delete at end, or this is one way of doing, or I can also implement stack by using insert at begin and then delete at begin. Yes. So if you try to implement stack by using a linked list, I can implement in these two ways. So whenever, so if you observe this insertion at ending, actually we have some technical terms which will be used for stack. So what are those? Actually push and pop. Yes. So whenever it is push, implement insert at end, and whenever it is pop, implement delete at end. Okay, so insertion and deletion, if done from the same end of a linked list, then it works like a stack. Yes or no? Yes or no, guys? Yes, any doubt in this? So if you observe, okay, so if you want to implement a linked list, if I want to implement a stack by using a linked list, so we have seen all these functions. So we have seen what is insertion at end, deletion at end, insertion at beginning, deletion at beginning. Yes, if we just want to implement a stack using a linked list, so just call push is nothing but insertion at end, pop is nothing but deletion at end. Or I can also implement this thing by using insertion at begin and delete at beginning. Yes or no? Any doubts in this? Excuse me. Yes, guys. Do you have any doubt in this? Why it is insert at end, delete at end, insert at beginning, and delete at beginning? Okay. So this is one way of implementing a stack using linked list. Okay. So now what will we do? Okay. So this is actually it's already done. Yeah. So give me just 1 minute. I'm just copying that single linked list, all those things. Okay, give me just 1 minute. 1 minute. Yes. Okay. So the same code which I'm going to copy here. So this is actually a single linked list insert at begin and delete at begin. Okay. So now instead of naming it as single linked list, okay, I am naming it as a stack. Okay. So now my class name is stack. So, but here I am implementing a stack by using one of this method. What is that method? Insert at beginning, delete at beginning. Okay. So here just I'm showing push and pop for you. Okay. So now if I want to create a stack, I'm just writing A is equal to stack of. Okay. So after then, yeah. Even if you want to name these instead of naming it as insert at begin, okay. So you can also name it as pop. It's your choice. Okay, so you can name it as pop or insert at beginning. So for now I'll just show you. Okay, so what okay, I'm doing insert at beginning for 5 times, so you'll just clearly understand. Okay, so insert at begin of 1. So here normally I'm inserting, actually you can take a for loop also, but you should understand, right? So I'm just showing it here. Insert at begin for I am doing it for 4 times. Okay, so let me take my numbers as 10, 11, 12, 13 as my elements. Okay, and yes, okay. So after then, so this is actually nothing but push. Yes, so this is also nothing but pushing. So popping is what? Popping is nothing but deleting. Okay, so if you observe, okay, so yeah, so if you want to delete, okay, so yeah, so I'm just writing a dot delete at begin. Uh, delete at begin. Okay, so you need not to pass any element, right? So this whatever the element 10 will be deleted and will be having okay, so here element becomes, so if you observe now, let us call display. So I'm just doing, this is nothing but pop. Okay, so after then I'm calling display. So this is also nothing but push. So I'm just writing here push. Okay, so this is also push. So this is also push. Okay, and this is also push. Okay, and this is pop. Okay, yes guys, now tell me what should be the output. If it was a stack, what will be the output? Yes, okay. So now just see, so now we'll just try to implement it as a stack. Okay, so first what am I doing? So first I'm taking 10. Next I'm inserting 11. So I'm doing insert at beginning, right? So 11 will point to this one. Next 12. Next 13. Yes, so if you observe, first I'll be having 10, next I'll be having 11, next I'll be having 12, and next I'll be having 13. Okay, so after this, if I print stack, what should I get? Okay, so I should get my output as 13, 12, 11, and 10. So that is what we'll get here also. Insertion at beginning. Okay, and if I do pop, what happens? 13 should be deleted, and my output should be 12, 11, and 10. Okay, so here also, if I do delete at beginning, 13 will be deleted, and I'll get my output as 12, 11, and 10. So can I tell both this? If you do insertion at beginning and delete at beginning, it is working as a stack? Yes. Output should be after inserting the elements, after pushing the elements. So if you access, you should get 13, 12, 11, 10. Here also I'll get 13, 12, 11, 10. And after popping, that is not good, after popping an element, you should have 12, 11, and 10. Even here also you'll be having 12, 11, and 10. Yes. So if you want, just let me include display function also. So I'm just copying from single linked list. Okay. So I'm just copying it from single linked list. So this program which we wrote on the first day of data structures. Okay. So I'm just copying that and I'm just showing it to you. So I need to include this also here. Yeah. So after pushing all the elements, and then I'm calling display. Okay. And after deleting at beginning, I'm also calling display. So now check. And it is showing stack is not defined. So I should make it as capital S. Yes. So if you observe, you should got 13, 12, 11, 10. After then 12, 11, 10. Same as the stack. First you'll get 13, 12, 11, 10. So after then 13, 11, 10. Okay, so here I'm printing. So if you want a clarity, after pop. Okay. Uh, After pop, I'm just doing it. So if you observe, you'll get. So stack is, I'm inserting what? So I'm inserting 10, 11, 12, 13, but stack will be accessed in reverse manner. So obviously I got 13, 12, 11, 10. Yes. And after pop, okay, so first element should be deleted. So that is what is happening. So here first element is 13, so 13 got deleted. So you'll get 12, 11, and 10. Yes. So if you do insertion and deletion at the same end, then it acts like an what, stack of a linked list. Okay, guys. So this is by using linked list. So now we'll try to write a program. So generally we'll not use any linked list. If you want to create a stack in Python, we'll just use normal list, because that is very easy. Yes or no? So we'll just create okay, so we'll just create a stack by using a normal list. Yes. Okay, so we'll just create a stack by using normal list. So we'll see how to do that. Okay, so yes guys, so normally what are the operations does list have? Yes, so what are the operations I can be doing on stack? Push, pop. Okay, so and then peek. So what is peek? Yes guys, so what is peek? Peek always gives you the last element. Yes, so push, pop, peek, and even if you want make it as like length, so you can make it as length of the stack also. So even if you assume length, and any other operations which will be performing on stack, yeah, peek always gives the last element. Yes, Nabi. Okay, so yeah, this is about stack. Okay, yes guys, so now you people implement stack by using a list, not by using a linked list. So try to implement a stack by using a list. Actually that is very easy. Okay, so and you should have these methods. What are those methods? Push, pop, peek. So whenever you call, so we have seen implementing a stack by using a linked list. Okay, guys. Now we'll see implementing a list. Okay, so implementing a stack by using a list. Okay, so first thing, I don't have charging, so and power is not there, so I'll directly write it. Okay, yes, guys. So I'm just creating a class called stack. So because whenever I try to implement a class, okay, so what will we do? So whenever we try to implement it by using a class, we can create n number of stacks. Okay, so in this stack, okay, so I'm taking a constructor. Okay, so in this constructor, what am I doing? So normally we used to do head, but here what will we do? So I'll just create an empty list. Okay, so I'll just create an empty list. Okay, so how will we create an empty list? Yes. Okay, so initially it should have self. So I'm taking it as a self. Okay, so self dot. Okay, so this variable, yeah, so if you want to access it as, so if you want to make a variable as a stack, okay, so whatever it is, so I'm just writing self dot a is my variable. Okay, so it is nothing but a list. So I'm just creating an empty list. So here whatever I want to write, I'll write down now. So for example, I'm taking some methods. Okay, so I want to do push. So here I want to implement my method as push. So whatever I need to write, I'll be writing it here. Self. So whenever I call this thing, push operation will be done. Okay, so and then I'll be taking one more element, one more method as pop. Okay, so self. So this here I should write uh, code for pop. Yes. Okay. Next definition of next one more method is what? One more method is peak. Yes. So what this peak should give? So this peak should give the last element. And any other operations on stack? Yes, guys. Push, pop, peak, and any other operations on stack which we can perform on stack. Main is push and pop only. Yes. Okay. So if you want to do any operations on stack, yes, you can tell me. We can include those things as also methods. Okay. So now what will I do? For example, okay. So now I'm taking X as a stack. Okay. So here I'm creating a variable called stack. Okay. So now X acts like a stack. Yeah. Yeah. One more thing. So if you want so if you want to include one more thing as length of the stack, we can also implement definition of length. Length of the stack. Any method, any operation which you want to do. So I'll be making it as a method inside a class called stack. Okay. So now I'm creating a variable called stack. Okay. So now let us see what we need to do. And also display also should be there, right? So I should implement all the methods. Yes. One more method is display. Yes. I don't have time, so that's why I'm not giving you time, you people, to think all these things. Okay. So because there is no charging and I just have only, yeah, no problem, guys. I got power just now, so we can go slow. Need not to worry about time. Yes, guys. So now you people will write and tell me. So we need not to worry about time. I just got power. Okay. Uh, yes. So I'll be just implementing a stack by using a list. I'm not implementing a stack by using a linked list. We have already seen that implementing a stack using a linked list. So this is what. So whenever you want to create a list, whenever you want to create a stack, okay. So we'll just implement it by using a list, because list has already, by using a list it's very easy. Okay, so now this is a stack. Okay, so here whenever you want to do push operation, so you can just do x dot push of any particular element. So for example, I just want to do now, I just need to push n variables. So I'm just taking x is equal to int of input, Okay, so next what of I need to push n elements. For I in range of n. Okay, so now no problem, we can I can go slow. So for I in range of n, x dot push. Okay, so I'll be pushing n elements. So after then I'm writing x dot peak. That means it should give me the last element. Sorry, so x dot peak. Okay, so before this, let me check x dot length. Okay, so after then I'm writing x dot peak. Okay, so x dot peak. After then I'm writing x dot pop. Give me 1 minute. X dot pop. Let it be. So first we'll do one thing. So we'll first find the length. So after finding a length, we'll just display it, the entire stack once. Okay, so after displaying, I am accessing peak element. So after peak element, I am doing pop. After doing pop, again I am doing display. Okay, so any other methods? Push, pop, peak, length, and display. Fine. So after pop, let us just do one more time length. H. Okay. Uh, yes, guys. So now let us see what should be the input given. So fine, I'm giving 5 elements, and I'm giving 10, 20, 30, 40, 50. So I am pushing 10, 20, 30, 40, 50. Okay. Yes, guys. Now let us see how we want to implement first. So first we will do one thing. So first we will do one thing. Yes. So it's your choice how we want to implement stack. In that manner we can implement. Okay. So normally if I go stack, so generally what comes to your mind? Last in, first out. Yes. So let us just implement this thing. So last in, first out. Okay. So last in, first out is what I should always add an element at the end and remove an element. So fine. Okay. Now if I take list, so if I want implement it as a list, okay, and I need to do last in, first out. Yes. So for example, if I'm using 10, 20, so if I take this as a list, 10, 20, 30, 40, 50. Okay. So for pushing operation, I need to do last in. Yes. Okay. So tell me what should I do here? Yes. So now for push operation, okay. So under push operation, so tell me what should I do? So we'll just define all these methods. Yes. Aima, Aima, mute yourself. 5A1007. Haima. Yeah. Uh, yes, guys. Now we'll do this thing. So I want to implement push operation. So how can I implement push? That too I should do last in. So can anyone tell me what will be the definition or what will be this method's definition? What will be this method's definition? Okay, so fine. We'll come to that push and pop. So for example, I want to find this length of the list. So length of the, so at least tell me how can I find this length of this list? Any answers? How can I find the length of the list? Yes. No one knows how to find the length of the list. Exactly. Yes, Adana. So generally, if I want to find the length of the stack, I just need to find this length of the list called A. Yes. So how will I do that? Okay. So we can directly find, we have a method to find all those things, length of. Okay. So I'll be just using that method. So I'll be just using length of self dot A. Yes, that's it. So this will find out the length. So for example, if you want to print it here, you can just print it in this method, or if you want to return somewhere, you can just return. So here I'm just writing return, RETURN. Okay, so return length of this list. That is nothing but length of the stack. So now this list, A list acts like a stack. Okay, so for example, here I'm just writing as it is returning value, I'm just writing print statement. So length will return some value, right? So obviously if it is returning a value, I just need to print it. So it yeah, this is about finding the length of a stack. Okay, and coming to P, display. So what about display? I just need to display all the elements. Yes. So if I want to display all the elements, what I need to do? I just need to call print method. Yes, just in the print, write down self.a. That's it. So it will display all the elements. Yes or no? Yeah. So coming to the peak. Yes, peak should always display the last element. Yes. So if I want to display the last element, so tell me how can I display the last element? Yes. So if you want to display the last element, actually you need to know. Yeah. So I directly write print of. Yes. So how can I display the last element, guys? Can I directly write self dot a of negative indexing -1? Yes or no? Can I write self dot a of -1? It will always give you the last element. Okay. So in the same way, so normally, so here I'm just writing. So push will get a method, will get a variable, right, called x. Okay. So I'm just writing. So self dot a dot append. So we already have a method called append. It will always insert at the end. Okay. So I'm just writing append of x. Yes. So it will write self dot a dot append. Append will always give add element at the end. So if you observe 10, 20, 30, 40. Yes. Okay. So now coming to the pop. So for the pop, what I need to do, I need to delete at the beginning. So tell me what method I need to use. So this is the only thing uh, you might have, I have already explained the method what we need to use. Yes. Okay. So we have a method to remove the first element. Yes. So yeah, we have a method called pop. Okay. So what is that pop does? Pop always removes the last element. Or we can also give yes. Okay. So normally if I write, if you want to do, yeah, so we can just write, yes guys. So self dot a dot pop. Okay. So we have a method called pop. Pop always removes the last element. Yes, that's it. So I just need to do whatever the element which is inserted last, that should be given first stage. So if you observe, if I do 10, 20, 30, 40, 50, if I do pop, 50 should be deleted. So we have a method called pop. So we have append, we also have pop. Okay. So here what am I doing? I'm doing insertion at end and deletion at end. Yes or no? Insertion at end and deletion at end. Yes. Okay. So we can also do the same thing in an other fashion also. Okay. So for example, so if you observe, uh, so first let us try to implement it. So that is why actually by using a list, implementing stack is very easy because we already have inbuilt methods. So just make use of those inbuilt methods. Push. Okay. So for push, I'm using append. Okay. So for pop, we already have a method called pop, so that I'm using. For peak, I need to get the last element, so I'm just using a of -1. So for length, we already have a length. For display, yeah. So coming to the display, so display, can I just write print of self.a? So for example, so if I just take these things, uh, yeah. So 1 minute. So if I'm giving 10, 20, 30, 40, 50. And what my output should be? My output should be 50, 40, 30, 20, and 10. But if I use print, what will be my output? My output will be 10, 20, 30, 40, 50. Yes or no? Yes. So if I give 10, 20, 30, 40, 50, and if I just use print of self dot a, what will my output? My output will be 10, 20, 30, 40, 50. But I want the output in reverse manner. So if I want the output in reverse manner, what should I do? If you want, you can use slicing, or if you want, you can use a loop also. Okay, so find out the length and print it from the reverse, or just use slicing. Yes guys, so I'm just using a slicing. I hope you know what am I doing here. First, let me remove these things. So I've just written colon colon minus 1. Yeah, reversed. Yes, okay. So yeah, so if you just need to print it in reverse, right? So for that I'm reading a minus 1. Yes, so here only length is returning a value. So for that reason I've written print. So now let us check what will be the output. It is not init, it is int. Okay, yeah. For push, we need to give elements, right? X is a stack. Okay, so here I need to take an element. So I am taking element as y. Y is equal to int of input. Okay, and I am passing y. Okay. Yes, guys. Give me just 1 minute. So what is an error? Push missing one required positional element. Sent, right? In which line? Type error. Missing one required positional argument x. Okay, 1 minute. So instead of x, maybe it is getting confused because of this. So let us take y on. One minute. Line 24. Okay. X dot push of y. Missing one required positional argument. What is the error? X is a stack. N is nothing but number of variables. So let me check. 5, 10, 20, 30, 40, 50. Okay, nothing wrong. For I in range of n, y is equal to int of input. So I'll be taking y. So x dot push. Let me remove all those things first. So let me just check. X is a stack. X dot display. Okay, here display self, length self, peak self, push. I also have kept self. missing one required positional argument y. Push of y. One minute. First, let me print y, and then we'll see. Sorry. Give me 1 minute, guys. So I'm checking. It is showing some error. Type error. Push. Missing one required positional argument y. Self e. Okay. Give me 1 minute, guys. Let me check. Okay. Give me 1 minute. I'm just checking the code. So let me execute and check it once. Yeah. Give me just 1 minute. I'm checking the code. Yeah. Self dot a dot append of y. Uh, just give me 1 minute. Stack class stack constructor self. I'm just creating one instance variable which is nothing but a. So I just need to call self dot a dot append of y. Okay, just give me 1 minute. Okay. So let me just call instead of this x dot push of 10. What is wrong in this? So here I'm just passing one variable, but here I've written self comma y. Yes, guys. Did you are you finding any error here? Yes, yes. We'll just complete the stack and then we'll leave. So, can anyone find any error here? Missing one required positional argument y. Yes. So I've just created a class called stack. In this, I've just used a method called push. In that, I'm calling self.a.append of y. And I'm calling a method by using, okay. What is the error? I should call class name with brackets. So now let me check. Yeah. Oh God. So now the same code which I have written previously. Yes. So I'm just displaying it, pushing all the elements in the display. So if you observe, it is showing 10, 20, 30, 40, 50. So I'm getting 50, 40, 30, 20, 10. Okay. So here the what is the problem? The problem is here it is showing it as a list. Yes. If you don't want the output as a list, okay. So then instead of slicing, what can we do? Okay. So if I make it as a slicing, so I'm getting in the reverse order 50, 40, 30, 20, 10. Okay. So if you don't want it as a slicing or with the brackets, then what we can do? Okay. So now what am I doing? So now I'm taking first length. L is equal to length of. So I just need to call a method called length, right? So I'm just calling self dot length. So I'm calling this method, or if you are getting confused, so just call method for self dot a. Okay, and now print all the elements for I in range of. Okay, so for I in range of L, comma. Okay, so normally, how can we write decrement operator here? Yes. Okay, so I am writing L, comma. So L is what? L is the L is the length value. Yes. So until length, I should go up for fine. For example, I'm writing 0. And how will you write decrement in the for loop? I just need to write -1. Okay, and then I am writing print of. Okay, so if you just want to write self dot a index values, right? I just need to write index value. So I should write length or length -1. So obviously you need to write length -1 because L is nothing but length of the index. Length of the index will be 5, but it will be 0, 1, 2, 3, 4 only. So now let me execute. So every time you are getting length is 5, but every time you are getting -1. Okay, fine. For I in 0, always length of it is not L -1, it should be I -1 because L -1 is always same. L comma 0 comma -1. Yes. Okay. So if you observe, we will get one element will not be printed. So if you observe 50, 40, 30, 20, 10. So if you observe, if you want to write some statement, print stack elements. Okay, so I have given 10, 20, 30, 40, 50, but I'm getting 50, 40, 30, 20, and 10. Yes. So here by writing -1, we can decrement the for loop. Okay. So let me just check whether all the functions are working or not. So x dot length. So, but this will return value, right? So as this returns a value, I just need to write print. Let me check. Yeah, length is 5. Next, x dot peak. I'm just checking whether all the methods are working or not. So I don't know why every time I'm putting comma here. X dot peak. So what is x dot peak? X dot peak should give me the last element. So what is the last element? Obviously 50. Yes, last element is 50. So this is also working. Next, length obviously is working. Next, x dot pop. X dot pop. After popping, I need to display. X dot display. Yes. Yeah. So 1 minute. So here let me make it clear. So after popping, I'm just writing print after pop. So if we observe first elements are 10, 20, 30, 40, 50. So if I print elements, I'm getting in reverse manner. Obviously it is a stack. So after then 5 is what? Length of the stack. So 50 is nothing but peak. So after popping, I'm getting 40, 30, 20, 10. Yes. Yes, guys, this is nothing but stack implementation by using a list. Yes, any doubts in this? Stack implementation by using a list. Yes, I know today we had so many problems because so many times my account like internet issue was there. Okay, so from tomorrow I'll take care of it. Fine, guys. If you don't have any doubts, please send your roll numbers in the group or in the chat box, and then you can leave. Enough for the day. From tomorrow, tomorrow we'll see stacks, queues, and then trees and graphs. Yes, Sadhana, you have raised hand. Any doubt? Monica, your speaker is on. Please mute yourself. Yeah, guys. If you don't have any doubts, yes, you can
సార్
Yeah.
సార్ ఐడి సెండ్ అవ్వట్లేదు సార్. విజ్ఞాన్ ఇస్ నాట్ ఇన్ ద మీటింగ్ అని వస్తుంది.
Okay. Yes, guys. So many people have raised your hand. Can you know who is speaking? Harika.
హారిక సార్.
Yeah, Harika. Send your roll number. Tell me your roll number.
18891A05H0.
1 minute. 18891
A05H0.
A05
H0.
H0. Okay. Give me 1 minute. 18891
A05H0 sir.
A5H0. Harika.
Yes sir.
It is showing. Okay. Yes, guys. Sai Krishna, Khyati, you people have raised your hands. Any problem?
Same problem, sir.
Yeah. 1 minute. Vaishnavi. Vaishnavi, are you there?
Yes, sir.
Tell me your roll number.
188
188
91A0
91A0
530.
530. Your name is Vaishnavi, right?
Yes, sir.
I'm sending roll numbers. So if there is any mistake, please respond. If there are no mistakes, and if you don't have any doubts, you can leave. Next, Koti, are you there?
Yes, sir.
Tell me your roll number.
1889
1889
1A0
1A0
5F3.
5F3.
Yes, sir.
Okay. Yeah, I've sent roll number. If there is any mistake, please respond. Santoshi. Santoshi, are you there?
Yes, sir.
Yeah, tell me your roll number. Yes, Santoshi. I cannot hear you. Is your roll number 518? Yeah. I've sent a number. So if there is any mistake, tell me. Okay. So Sai Krishna, are you there?
Yes, sir.
Tell me your roll number.
1889
1889
1A0
1A0
5A8.
5A8.
Yes, sir.
Sai Krishna. Yes, Meghana, are you there?
Yes, sir.
18891A0
515.
515. Meghana. Yes. If there is any mistake, please tell me. Next, Khyati.
Yes sir.
Khyati, are you there?
Yes sir. 19 1A0.
Hello, Khyati.
Sir.
Yes, tell me your roll number.
18.
18891A0512. Is it correct?
Yes sir.
Yes. Suvarna.
1889
1 minute. 1889
180 555.
1A0555.
Yes, sir.
Yes. Akanksha, are you there?
Sir,
Yeah, tell me your roll number.
18891A0 548.
548. Akanksha. 1 minute. Yes, Archana, are you there? Archana. Satvika.
Yes,
Yeah, tell me your roll number.
1889 1A0 5G2.
5G2 Satvika. Kashyap, are you there?
Yes, sir.
Yeah, tell me your roll number.
1889 105A5.
5A5.
Yes, sir.
1 minute, 1 minute. Yeah, Mallikarjun.
Yes, sir.
5H4 is your roll number, right?
Yes, sir.
1 minute. Yes, guys, if you have sent your roll numbers, you can leave. Haima. Haima, are you there? Fine.
Yes, sir.
Yeah. Did you send your roll number?
Yes, sir.
Yeah, fine. Tarun, 587, Tarun.
Yes, sir.
Yeah. Is 587 your roll number?
Yes, sir.
Yeah. Okay.
Sir, Ketan, sir. Yes, sir.
Okay, okay. 1 minute. Yeah, Tarun, no problem. Roll number is correct, right?
Yes, sir.
Yeah. Yes, Archana, if you are there, respond.
18571, sir.
18571. Yeah, fine, fine. Praveen,
Sir,
have you sent your roll number?
18891
18891
A0 528, sir.
528. Praveen.
8. Yes, sir.
Yeah. Suma, Madan Mohan, are you people there?